Course 3, Investigation 7 is all about probability, but not just probability. We are trying to simulate different scenarios that could be very tough in real life to actually do the experiment. So we would use probability simulations to conduct an experiment to basically simulate what it would be like in real life. So I'm going to go ahead and read this to talk about what's the situation that we're in first. So a cereal company claims on the box 1 in 3 win a free movie pass. If you decide to purchase the cereal, what is the probability it contains a movie pass? The cereal box indicates that the probability is 1/3. That's theoretical, which means out of all of the cereal boxes produced for the context, a third contain a free pass. So on average, 1 in 3 boxes is a winner. But unfortunately, this doesn't mean that if we buy 3 boxes, I will get 1 winner. It's not guaranteed. That's theoretically what would happen. So let's figure out in real life, in an experiment, what might happen. So for the simulation, we need a spinner that looks like this. You could make this with paper and a little pin. But basically, we want a spinner that a third of the space is a winner space and 2/3 is a not winner space. Now, I know I don't have the materials to do a real spinner, so online you can use a site that, there's lots of them out there, but I like wheeldecide.com. And I've created a spinner. You can do the same by just going down when you get to the site and plugging in winner, not winner, and not winner to represent 3 sections, 1 of them being winner, 2 of them being not winner, just like those boxes. So that we can go ahead and spin in order to figure out what is our experimental probability. So you can do this as well if you don't have the materials to actually create a spinner. So this is our first activity. And yes, when you do make it in real life, your sections would be 120 degrees each, but with ours, we already have it created. So we're going to use this table in order to keep track of our results, but instead of just 3 trials, we're actually going to do 6 total trials so that we have plenty of information about this. So we have trial 1, trial 2, trial 3, 4, 5, and 6. So I'm going to be flipping back and forth a little bit, but you can go ahead and do this. I'll show you the first few spins and then I'll pause the video and come back when we have our results. But when we spin, we see that our first one is a not winner. The second one is also a not winner. And then our third one is a not winner. So when we go back to our table, we say not winner, so I'll represent that with an N, no, no, and no. So at least 1 winner. Within those 3 trials, did we get a winner? And we would say no. So we'll do it again. And we'll do our 3 spins. All right, we got a not winner, a winner, awesome. So we got a movie ticket in that cereal box, and then a not winner. So we go back to our table once again. We say not winner, winner, not winner. And so did we get at least 1 winner? We would say yes, showing that in that experiment, it did actually come out like the theoretical probability. So you can go ahead and do all of your 6 trials just like I did. I'm going to pause this video for a second and come back when I have my results. All right, so I have completed my experiment here, and you can see that in trials 3, 4, 5, and 6, 3 of 4 and 5 all had winners within them, but trial 6 did not. So if I were to go on and answer some questions, for each trial, simulate the purchase, that's what we just did. We created our table, good. And 3, what is our experimental probability of having at least 1 winner after purchasing those 3 cereal boxes? Well, we're actually looking at this column here, saying out of our 6 trials, big trials, how many did we get as winners? And in our case, in my case, I got 4 out of 6. Yours might look different, but regardless, we get 2/3 as my experimental probability. Actually, same as theirs, but it doesn't necessarily mean that it's always going to happen like that. So let's answer some questions about this. Number one, what did one spin of the spinner represent? Well, in real life, that spinner represented one box being opened. And then if I have 3 spins, what does that represent? Well, that represents our 3 boxes being opened and seeing if we have a winner. So what did it mean when we stopped on a winner? Well, there was a movie ticket in there. And not a winner would be having no ticket. All right, so a spinner is a good idea, but there are other ways to conduct this simulation. Let's decide if any of these 5 options would work. Remember, we need it to be a ratio of 1 winner to 2 not winners. A says 2 red cards and 1 black card. Well, that would work out pretty well because my 2 red cards could represent my no winners and my 1 black card would be my winner. Meaning that if I had those 3 cards and I shuffled them up and randomly picked one, then I could figure out if I got a not winner or a winner. Let's see, a coin. We only have heads and tails on a coin, so that would mean that our probability would be 50-50. That actually doesn't work in this situation. We don't have enough spaces for those 2 not winners, 1 winner. 3 red marbles. Although we have 3 pieces here, we can't really determine what would be the winner and not winner. With them all being the same color, that wouldn't work very well. So we actually couldn't use those 3 red marbles. 1 red, 1 white, 1 blue. We have 3 different pieces, which is good. And even though they're all different colors, we could determine beforehand, we could say the red and white ones are my not winners and the blue one is my winner. And that would give me my 1 to 2 ratio here. 1 white or 1 winner to 2 not winners. And then a number cube. This has 6 different options, but I could actually split this up into something that would work. I could say something like 1 and 2 would be a not winner. 3 and 4 would be a not winner. And then 5 and 6 would be a winner. So if I rolled a 1 through 4, that would be my not winners. And my winners would be just 5 and 6. That would be an even ratio compared to what we began with. All right, number 6. We use simulation when the theoretical probability is difficult to compute. Why is it impractical to actually do this in real life? Well, I'm sure you can think of lots of different ideas here, but when we think about these cereal boxes, I don't know about you, but if I went to the store and actually did this experiment with all of those boxes of cereal, in our case, 18 boxes of cereal, number 1, that's a lot of money to use on an experiment like this. Number 2, I don't know what I'm going to do with all of those open boxes of cereal because I probably couldn't eat them all within a timely manner. So it's kind of a waste of resources, of time, of money, you name it. So we do this experiment in basically in a simulation rather than reality. And then number 7, assuming a large number of cereal boxes were made for the contest, one can use probability theory, okay, much more complicated than what we get to in this book, and not actually simulation, in order to show that the theoretical probability of having at least 1 winner after purchasing 3 cereal boxes is actually 19/27. What is the difference between the theoretical probability, which is 19/27, so difference meaning subtraction, difference between theoretical probability and our experimental probability? So why is it important to conduct mini trials when computing an experimental probability? Let's first answer this question about the difference between these two. So we're saying this is my theoretical probability, this is my experimental. I want to know the difference, how much is between these. So when we're subtracting fractions, of course, I'm going to get common denominators. In this case, 27 will work just fine. And so for this one, I'm going to have to multiply by 9/9 to get there. And ends up that there's not a lot of difference, only 1/27 between my theoretical and experimental. Now, yours could be quite a bit different than the theoretical. The reason that it's important to conduct many trials, as you can imagine, the more trials that we do, the closer it will get to theoretical probability. So your experimental probability could have ended up something like 3 over 3, or 1 out of 3, or 5 out of 6. Very different from the theoretical. The more experiments that you would do, the better it would actually turn out to be. Okay, now I'm not going to actually go through each one of these. I'm going to stop this video quite soon here. But this is something that you can do to try this out for activity number 2. What this is asking you to do is you have 3 different situations. Just like we did with the serial above, you need to come up with a way to simulate these experiments using different probability materials. So I'll read this here. Read each one of the following descriptions of events and explain how you would simulate each one. Then choose one of the events and conduct a simulation. Select a simulation tool for the experiment, draw the chart you would use, and actually do the experiment. I'll just talk through number 1. A basketball player makes an average of 4 in 6 free throws. If he shoots 3 free throws in a game, what's the probability he makes all of them? Well, this would take some time to do in real life, although a little bit easier than the serial one. What I would do in this is I would actually use a number cube because that's already split into 6 perfect spaces. And then I would say, well, I need 4 of them to represent making a basket. So maybe 1, 2, 3, and 4 would be making a basket. And then I would say 5 and 6 would be not making the basket. He missed. And then, just like we would do with the serial, I would do some trials that each have 3 in them. Okay, basket 1, basket 2, basket 3, and then did he make it? And then I would say yes or no. So that just like the serial one, I could do multiple different trial sets to figure it out. So all I would have to do instead of having a basketball hoop, I would just use my number cube to roll multiple different times. So similar to that, 2 and 3, go ahead and figure out what would you do for that simulation, what probability material would you use, and go ahead and try the experiment, okay? So that's kind of the general idea of this investigation, taking things that are hard to do in real life and conducting a simulation rather than actually doing the experiment in real life. So I hope this helps with your studying and for homework.